Hey guys, so yesterday you were introduced to trigonometry and we went over how to find different angles using the tangent ratio. Today we're also going to be using the tangent ratio, but we're going to be looking at how to find missing side lengths in a right triangle. So this is lesson 2.2, finding side lengths with tangent. Just like when we're finding angles with any of our trig ratios, your very first step should be to label the sides of your triangle. So the opposite side, the hypotenuse, and the adjacent side. Then you're going to plug in one of your known side lengths and the angle that you're dealing with. Then you're going to multiply and possibly divide if needed in order to isolate the variable that you're looking for. And then lastly, you're going to take the tan of the angle. So make sure that when you're finding a side length, you're using the tan button, not the tan inverse that we use when we're finding an angle. So it's pretty straightforward. We're just going to go through two different examples depending on which side it is that we're looking for, and that's it. So in the first example here, I've given you an angle of 50 degrees. I've told you that one of the sides is 8 centimeters and the other is the one that we're looking for. So step one, of course, label our sides. Across from the right angle is our hypotenuse. Across from the angle that we're dealing with is our opposite side. And then the other side, which is beside the angle that we're dealing with, but not the hypotenuse, is our adjacent side. Then we're going to use the same formula that we used yesterday. So the tan of an angle is equal to the opposite divided by the adjacent side. This time, however, we are going to actually plug in a number where that angle sign is. So it's going to be tan of 50 degrees, since our angle is 50 degrees. Then we're going to plug in x for our opposite, that's what we're looking for, and then 8 for our adjacent side. And then anytime we have a variable in a fraction like this, whatever is on the bottom needs to be the thing that moves. Because this is division, the opposite operation is multiplication. So I will multiply by 8 to cancel that out. And then what I do to one side, I must also do to the other. So times by 8. That leaves me with just an x on the right-hand side. And then on the other side, I'm going to plug this into my calculator as the tan of 50, close my bracket, times 8. And I get 9.53. So 9.53 centimeters is the length of my opposite side. Okay, next example, similar triangle. It's a right angle, it's organized the same way, but I've been given a different angle. This one is 46 degrees. Again, step one has to be label my sides. So across from the right triangle is my hypotenuse. Across from the angle that I'm dealing with is my opposite side, and then the other side is the adjacent. So you can see, depending on where in the triangle the angle I'm dealing with is, that's going to affect how I label my sides. My opposite side is now at the bottom. Previously, it was on the side. Okay, so that's why it's really important to start by labeling our sides. Then I'm going to start with the same formula. The tan of an angle is opposite over adjacent. I'm going to plug in my angle of 46 degrees. And this time, I'm given the opposite side. I'm looking for the adjacent side. Just like last time, when we have a fraction like this that involves a variable, the thing on the bottom has to be the one that moves. So even though my variable is now on the bottom, that still has to be the thing that moves. So I'm going to multiply by x to cancel that out, which means I also multiply the other side by x. That leaves me with the tan of 46 times x equals 11. And so my last step in order to get x by itself is to divide by the tan of 46. to cancel that out, which means I also need to divide the other side by the tan of 46. That leaves me with x equals, and I'll go back to my calculator, 11 divided by the tan of 46. And I get 10.62 centimeters as my answer. Now, some of you may be wondering, or you may want to actually solve for what the tan of 46 is before dividing it, or in the case of the previous example, before multiplying it, because I could just say, what's the tan of 46? And it would pop out my answer. The reason we don't do this is because you might round this to like, you know, it's 1.03. I could probably just round that to 1.0. And then if we do 11 divided by 1.0, you're not going to get the right answer. Okay, so my point of that is save doing your tan or whatever trig ratio we're talking about until the very end. It's just going to make your final answer more accurate. Okay. But other than that, that's it for today's lesson. Let me know if you have any questions about it.